This is a Chemokinetics podcast on thermodynamics, where the heat capacity will be discussed. Also, heat capacity under constant pressure and constant volume will be derived. The energy within a molecule comes in many forms, starting from the most fundamental, which is the energy contained within the mass of the particles or even bringing these components together to form atoms. These are the main concerns of a physicist or quantum chemist. However, to combustion chemists, the energy contained in bonds of a molecule, which is the source and sink of heat during a chemical reaction, and the energy of the entire molecule moving through space is of importance. All other sources of energy remain basically constant and can be ignored within these models. To relate the internal energy to temperature, pressure, and volume changes, we define two macroscopic variables for the calorific equations of state. U, which is dependent on T and V, and H, which is dependent on T and P. Thermodynamics is fundamentally the study of change. Absolute macroscopic quantities cannot be measured. We can only compare. See the differences before and after. Think of the first law dealing with the energy of the initial and final states. So a fundamental question in thermodynamics is how does the energy of a system change? To study the changes of energy, let us look at the energetic quantities H with respect to T and P, and U with respect to T and V. Looking at the differential with respect to the independent variables. H is dependent on T and V, and dH is the differential with respect to T and dt and dB. U is dependent on T and V, so the differential du is dependent on dt and dV. The internal energy quantities H and U have not only a dependence on T, but also on P and V respectively. In a system with no PV work, i.e. P or V is constant, we can see that there are two useful quantities emerge, C sub P and C sub V. These represent how the internal energy of a molecule changes with respect to temperature, the molecule's capacity to store heat. This quantity is often called heat capacity.